Hi there. It's been a little bit since I was last on, and the reason for that is we're right in the middle of the COVID-19 pandemic. For a lot of you, that might mean a lot of extra time, and while it has meant more time at home for me, it's actually meant a lot more work. So I study at uni and I also do some tutoring at uni, and what this has meant is a lot more time physically at the computer doing both the study and the tutoring. So in the tutoring side, what I've been doing is, as I've mentioned before, I teach assembly language. So I've been doing videos on how to program, in this case, a calculator application, but prior to that it was doing some multiplexing using common data ports for the 7-segment display. And where that's normally a 1 hour tutorial, to video it, edit it all up and so forth is taking me about 3 hours. So there's a lot of extra time there, and then just trying to do my online studies is also taking a lot of extra time without having access to all the equipment I need. But anyway, we're working through that. Hope you're all keeping safe and healthy and staying indoors wherever possible. Now, I've had a viewer request, and that was how to first of all convert binary numbers to hexadecimal and vice versa, and then how to actually add hexadecimal numbers. Now, this is a little bit out of what I normally do, being hardware based things, but sometimes I forget that we need to start back at the basics, and so I thought it's a good time to jump back in and freshen up my memory on how to do it and help some of you guys out. So hopefully this helps. Right, we've got a bunch of pens ready. We'll go through this step by step. So first of all, let's look at the hexadecimal counting system. So I'll just write across the top here. So we're going to have a hex, which is called base 16. And the reason it's base 16 is it has 16 values in it. And they start off at 0. Don't make the mistake of starting at 1. It's actually 0. So we go from, she'll go across here. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to leave a little gap after 9. Then we'll go A, B, C, D, E, F. So that is our full number range in hexadecimal. If we then write down below it decimal, which is base 10, we again have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is like going back to primary school and learning to count. And that is our 10, that's our base 10, which is why I left a gap there. We then go 10, 11, 12, 13, 14, 15. So that's the direct equivalence in those lots of numbers. And we then have another base, which is binary, called base 2. So base 2 only has the values of 1 and 0, but we can represent any number by that. So I'm going to just do it in 4-bit binary, which will tie in with our hexadecimal. So binary has the numbers 8, 4, 2, 1, from which we can make any number up to 15, so from 0 to 15. And the way that we would do that is if we said that we wanted the number 5. So 5, we need to add up the values of 4 and 1. So we can put 1s in those two spots, and we just fill the gaps in with zeros. If we wanted C, which is 12, so I need 8 plus 4. So we go 1, 1, 0, 0. So that's how we create our numbers in binary. Now we'll do some adding in binary. And it's really very, very simple. So I'll take these two numbers that we've got here. So I'll just draw a line under it, and let's say we're going to be adding those two there. And I'll write alongside of them the values we had. So it was 5, and what was the other one? 12, which is C, or C. Okay, so because we've only got digits 1 and 0 to play with in binary, what we do is we go through and say, okay, 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 2, but we can't write 2. What 2 is represented by in binary is 1, 0. So we've basically got one lot of 2 and 0 lots of 1, and all the rest is 0, so we just ignore them. So we write the 0 here, and we carry like we would in normal maths. Put the 1 up there. So that means we've got 0 plus 1, which again is 2. So we've got 0, and the remainder gets carried over there. So if I was to then break this up to being two 4-digit binary values, 4 bits, so this would be 0, 0, 0, I would have the value of 1, 1. Okay, so what does this 1, 1 represent? It's actually the hexadecimal number. So we know that if I was to do this part here, if I added 5 and 12, we will have 17 in decimal. If I was to add over here my next base, so you probably may have noticed that this is doubling each time. So 2 doubles to 4, doubles to 8. So the next digit over would be 16. So I've got one lot of 16 plus one lot of 1, which adds together and makes 17. So that's correct. So the hexadecimal portion of it, I'll just put these down in orange. Hexadecimal, we basically take the 2 lots of 4 and each part becomes a digit. So that would get written as just 1, 1 in hex, and we can represent that it's hex in a couple of ways. We can put a H after it, or we could write it as 0x11, which in programming is a well-used method for hexadecimal. So that's a basic count in binary. So it's literally just consider that your decimal 2 is 1, 0, and you just add the value straight through, and anywhere where you've got a value that adds up to 2, you put a 0 down and carry the 1 over. Now we'll look at doing the same thing but adding it directly in hexadecimal. So we'll use the same numbers at the moment. So I'm going to go 5 hex plus C hex. So we can literally ignore the H in here. So what is taking the value C and adding 5 to it? So C plus 5 is 1, 2, 3, 4, 5 positions up. And because we've looped over, we have to put a 1 at the start. I'm not sure if I'm explaining this well, but I'll try and pull it all together. So we've basically, once we get to 15 or F and we loop over, the values become 1, 0, 1, 1, 1, 2, and then they repeat on to 1, F. Okay, so basically we've gone from here, from where were we? C, 12. We've counted 5 further on, so 12, 13, 14, 15, 16, 17, which gives us 1, 1. So the answer to this is 1, 1 hex. So doing it with just single digits, reasonably straightforward. So let's bring it up to something a little bit more complex. And what we'll do is we'll take the number 4A6 and to that we will add 1B3. So 6 plus 3, simple, it's 9 in both hexadecimal and decimal. But A plus B is a little bit more complex. So if we're taking A, which is 10, and we're adding B, which is 11, what happens? So if we just said we have A plus B in hexadecimal, if we convert that to a normal decimal, it would be 21. So what does 21 hexadecimal look like? Well, it's F 10, 11, 12, 13, 14, 15. So that is equivalent to 15 in hexadecimal. So like we did before, we put the 5 here and we carry the 1. We then do 4 plus 1 plus 1 is 6, and that is our answer in hexadecimal. So I feel this can be a little bit confusing, and I actually find adding these larger numbers in binary a little bit easier. So let's go through and do that. We'll just choose a different pen number. So first of all, let's convert the numbers. So 4 is 0, 1, 0, 0. A is 1, 0, 1, 0. 6 is 0, 1, 1, 0. And then for the next line, we've got 1 is 0, 0, 0, 0, 1. B is 1, 0, 1, 1. And 3 is 0, 0, 1, 1. So I've just converted each of these numbers through to their relevant binary number. We'll put a line under there and go through and do the adding like we did earlier. So 0 plus 1 is 1. 1 plus 1 is 2, which we have a 0 and carry the 1. 1 plus 1 is 2, so 0, carry the 1. 0 plus 0 plus 1 is 1. 0 plus 1, 1. 2, so 0 and carry. 1, 2, so 0 carry. 1 and 1 is 2, so 0 carry. 0 and 1 is 1, 1 and 0 is 1, and 0. Alright, so assuming I've done all this correctly, I'll change colours again. If I convert each of these lots of 4 back, okay, so I've got 8 and 1 is 9, so first digit's correct. 4 and 1 is 5, second digit is correct. And 4 and 2 is 6, so third digit is correct. So for me, converting to binary may be an extra step, but it's a fairly quick one once you're used to counting with binary, and then adding in binary is actually easier than this process of trying to work out all these conversions through in hexadecimal. I just find that in my own mind a lot easier. So hopefully this has clarified it for my viewer. His name is Favor, so Favor, thank you for asking the question. And if any of you have questions, please do ask them. Sometimes I just directly answer, other times I'll do a video, and I'd love for you to subscribe to the channel just to help me keep these things going. Thank you.